Hi guys, so today we're going to start a new chapter. Today we're going to start chapter 9, and this chapter is going to deal with our chemical reactions and equations. So we're taking that bonding to the next level, and we're going to learn about equations. So today we're going to do lesson 1, understanding chemical reactions. And chemical reactions are changes in matter. And remember, we have a physical change and chemical changes. So a physical change, just for your reference, does not produce new substances. It is the same substance before and after the change. A chemical change is where one or more substances change into a new substance, and that new substance has different properties. We also call a chemical change a chemical reaction. The chemical reaction is a process in which atoms of one or more substance rearrange to form new substances. And there are some signs of a chemical reaction. They include a change in color, a change in odor, formation of bubbles, formation of a precipitate, and also a change in energy. Signs are indicators, but not proof. So the only sure way to know a chemical reaction has occurred is to see if it has new chemical properties. So what happens in a chemical reaction? So what happens is one or more substances react to form one or more new substances. And our atoms will rearrange. So atoms have a fixed arrangement, and they change that fixed arrangement to form new compounds with new properties. So if you look at this, you have methane plus oxygen, which then becomes carbon dioxide and water. So these two change into completely new combinations over here of the same elements. During a chemical reaction, bonds break and new bonds form. So atoms rearrange when chemical bonds break apart, and then those new bonds form new molecules. So here, these two broke apart, and then they are rearranging to be bound to each other. So before they were bound together, and now they are bound to each other. Chemical equations are a description of the reaction using element symbols and chemical formulas. So here we've been working with these a long time, so we have our symbols, and then the symbols represent which elements are actually in the equation, and the formulas represent our compounds, so how they are actually bound together. Then we're going to learn to count how many compounds are on each side of the equation. So this does it for us. So carbon, there is no number here. We know that automatically means there is 1. Hydrogen, there's a 4 after. So we know there are 4 hydrogens because that 4 is attached to the hydrogen. Here's where it gets a little tricky. Oxygen here has a 2 in front of it and a 2 after. So what that means is we have to multiply these two together. So 2 times 2 means that there are 4 oxygens here. So basically you have 2 molecules of 2 oxygens together. On the other side, again, there's nothing in front of carbon, so we still have 1. Oxygen, there's 2 here. But look, we have oxygen over here also. So that's a 1. So remember, 2 times 1 is 2. So 2 plus 2 equals 4. Hydrogen, the same as we did before. 2 times 2 is 4 hydrogen. So this 2 is in front of this whole molecule. That means we have to distribute it just like in math. The symbols, so our element symbols represent our elements, and they can be just one atom, or they can exist as 2 atoms joined together called a diatomic molecule, like H2. So this is 2 molecules of hydrogen. That's a diatomic molecule. Here we have 2 molecules of oxygen. Same thing, diatomic. There are 2 together. Chemical formulas have 2 or more different elements combined. So for example, is CO2. So you have carbon bound to 2 oxygens. When we write our chemical equation, this includes substances that react and substances that are produced. The reactants are substances in a chemical reaction, and the products are the substances produced. So our reactants are on the left side of the equation, and our products are on the right. They're designated by an arrow. So you can always tell the reactants point to the products because that's what's produced. So you usually have a reactant plus some reactant yields a product, either one product like in this equation or maybe 2. Okay. The law of conservation of mass states that the total mass of reactions before a chemical reaction is the same as the total mass of products after a chemical reaction. And our atoms are conserved. So that means whatever goes into the reaction has to also come out. No new atoms are created, and we don't destroy them at all. All right, there are the notes for today. Oh, sorry. So this means all equations are balanced. So the number of atoms in each element is the same before and after. So we must balance our equations, which equals the law of conservation of mass. That simply means what goes in must come out. And we are going to start practicing with that soon. All right. We balance our chemical reagents by counting atoms in the reactants and atoms in the products. We use coefficients to balance the number of atoms. The coefficient is a number placed in front of an element symbol or a chemical formula in an equation. So what we do is we add up the atoms. You can see that these are not equal to that. So because they're not equal, we have to then balance them. And we're going to go through that soon. And that's where we're going to end today. So please make